Alrighty guys, Mrs. Ackland here. We're going to make a video for IXL, angle criterion for similar triangles. There's also a learn with an example that you can click on to see an example completed for you, and there's also a video done by IXL. All right, let's take a look at our problem. It says triangle ABC and triangle DEF are shown below. Which statement is true? Triangle ABC is similar to triangle DEF, triangle ABC is not similar to triangle DEF, or there's not enough information to tell whether the triangles are similar. So we can see right off the bat here that we have some angle measures that are marked. So remember, for triangles to be similar, all three of their pairs of angles have to be the same between them. But something new that we learned in this lesson is the angle criterion for similar triangles. Okay, so what that says is that if you have just two pairs of angles that are congruent between two triangles, then you can say, without even checking the third pair, that the triangles are similar. Okay, so looking at these, I can see that we've got one pair of angles between them that are the same. So we've got the 78 and the 78. The other two are not the same. That does not mean that they're not similar, though, because we still have these third angles here that might be the same as, this one might be 55 and this one down here might be 47. Okay, so how are we going to figure out what one of the missing angles are? Well, you can pick either triangle. I'm going to choose triangle ABC, and we can figure out what angle B is. Remember, this is an old property that we learned about long ago, that the angles inside of a triangle always add up to 180, right? So all we have to do is take 180 minus 78 minus 55, okay, and we will see what happens here. So that's going to give us the measure of angle B. So 180 minus 78 minus 55 equals 47. Okay, so this angle right here is 47, and look at that, 47 on the triangle ABC, and we have 47 on triangle DEF. We do have two pairs of angles that are the same, so these triangles are similar. You could find the measure of angle D just to double check, but it would end up being 55 as well. All right, I'm going to go ahead and submit. Let's see what we get next. Okay, so for this one, it's sort of the same idea here. We have two pairs of angles that are the same. So we've got 52 and 52 that are the same. The other two are not the same, but we want to check to find out what U is first, U or Y, and see if U perhaps is 85, and then they would be similar. So let's go ahead and do that. Let's figure out what U is. Remember, we're just going to take 180, and we're going to subtract 43, and we're going to subtract 52, and we find that angle U is 85. And look at that. This worked out again. So if angle U is 85, then we do indeed have two pairs of matching angles between the two triangles. We could check Y, but Y would end up being 43. So they are similar. We could stop right there. So this angle criterion is just like a shortcut for not forcing us to find all three pairs of matching angles between the two triangles. It's just kind of shortens our work by a little bit here. All right, so let's take a look at this next one right here. Let's see, right off the bat, I don't have any matching angles yet, but I'm thinking let's go ahead and figure out what V is, okay? And if V happens to be 60, then we could, kind of keep going from there. So let's try that first. So let's see what V is. And with these triangles, I don't know, I kind of think of them as a puzzle. There's no like correct first thing to do. When I'm looking at this triangle right here, I see two things immediately that I can do. I see a triangle where we know two of the angles and one is missing. So I can use the triangle angle sum theorem for that. Subtract 45 and 75 from 180. That's what we're going to do in a moment. I also see this right here, this bow tie formation, vertical angles, and I know that this angle here is 45. So we'll mark that one if we get that far. But for right now, we're going to find V, okay? So we're going to do 180 minus 45 minus 75. Okay, ooh, and we do get 60. So let's go ahead and mark 60 right here. This is very cool. So that's 60. Okay, so we do have a pair of matching angles. And I just said that I had already noticed something else, which is that this angle here is 45 because they are vertical angles, and that is our second pair of matching angles. So two of the angles are 60, two of the angles are 45. I don't need to check angle Y. It has to be 75. These are going to be similar. Okay, let's keep on going. This one is just like the one that we just did. Okay, so maybe for this one, I'll start off by marking the 46. So this is vertical angles. This is 46, so this one over here must be 46. And we can say that that is a pair of matching angles. And I'm noticing that this angle up here is also 46. So, I mean, I could have highlighted this 46 and this 46, but that's okay. We'll keep on going. It doesn't matter, but you can only, each angle can only pair up with one angle from the other side. So like I can't have 46 matching with angle U and with angle S. We can only have one. All right, down here I do see that I have a triangle where I know two of the angles. We can find the missing angle by subtracting from 180. This little red square here means 90 degrees. So I'm going to take my calculator. I'm going to do 180 minus 46 minus 90 equals, and that is equal to 44. Okay, so I now know all three angles here. I know this is 90, I know this is 44, and I know this is 46. And it looks like I'm not going to get two pairs of angles that are going to match over here. Okay, I mean, we could find this third angle just to be sure. Let's just do that just to prove it to ourselves. So we could take 180 minus 46. Whoops. Minus 46 again for the other angle. Yeah, and that is equal to 88. Okay, so these two triangles do not have the same angles, so we are going to say that they are not similar. Let's keep on going. Okay, all right. So with this one right here, I'm going to go ahead and highlight the two angles that are the same. K and N are both equal to 26. And I guess I'll just start with this triangle up here, and I'm going to figure out what O is equal to with the triangle angle sum theorem. So we're going to take 180 minus 27. Oops. Minus 126, and we get 27 degrees. Ooh, and that does not match. Okay, so what I wanted this to be was 37 so that it would match. These are not the same. So we're going to say that these are not similar. And we could do the same thing over here. We could figure out what J is, but I feel quite certain that it's not going to be 126. So we'll hit submit on that one. Okay, let's try this one right here. So for this one, I see that I have a pair of matching angles. I've got the 45 right here and the 45 right here. Let's go ahead and figure out what angle D is. Okay, so we're hoping that angle D is 15. Or we could have looked for B and we could have hoped that it was 120. So we want the angles, all three pairs of angles to match between the two triangles. But again, in this lesson, they gave us a shortcut. If we know that two of the angles are the same, we don't really have to check that third angle. Okay, so 180 minus 120 minus 45 is equal to 15. Ooh, look at that. This is equal to 15. So we can stop right there. I've got two pairs of matching angles. I've got the 15s that match, the 45s that match, and with our new angle criterion, we don't need to check the third set. So these are similar. I'm hoping to get to one where it says there's not enough information so I can show you guys what that looks like. And I think we actually might have arrived at one of those. Okay. So we have very little information here. We don't have any angles that are marked. We do have these sides that have been marked with tick marks, and they're basically telling us that we have isosceles triangles. So I'll start over here. These both have single tick marks. So if those two sides have the same length, by the definition of an isosceles triangle, we know that G and H have the same angle measure as well. And we don't know what F is, but we know that they are the same. Okay. Same thing over here. These have double tick marks. So these two angles are the same as each other, but they're not the same as G and H. Okay. Necessarily. I'm just thinking out loud here. I suppose they could be, right? But they aren't necessarily the same. So I think we can stop right here and we can say that there's not enough information. Yeah, not enough information. I was about to make I'm pausing because I was about to make a stronger statement, and I was going to say that we know that K and L are not the same as G and H, but we don't even know that. They actually could be the same, right? Just because these side lengths are different doesn't mean that these angles are different. Okay, we just don't know. We don't know if they're the same. We don't know if they're not the same. I'm going to go ahead and say there's not enough information, and I'm going to submit. Okay, maybe we'll do this one more, and then I'll let you guys, and then I'll stop. I think we've touched on most of the different types. So this right here, where we have a single tick mark on all three sides, that is saying that all three sides are the same. That's an equilateral triangle, and we actually know the measures of these angles, believe it or not. Whenever all of the sides are the same, all of the angles are the same as well. And even more than that, they're all 60 degrees. Okay, so for this one, even though we didn't have the angle measures marked, and this right here, this is 90 degrees, these are not similar. So we didn't have any angle measures marked, but we do have enough information, and we're going to say that they are not similar to each other. All right, and they don't look similar, right? They don't even look like they're the same shape. I'm going to hit submit. All right, I'm going to stop right there. Good luck, guys. Let me know if you have any questions.